just let me make a very quick wrap-up. It's been a long day with a lot of topics, content, as I said, in which we have seen also some of the theoretical research, some research more practical, but especially we have seen also from Ericsson, Huawei, what are the trends, what is the vision for the 6G, so how we are going to 6G, and also especially thanks to team, so Telecom Italia Mobile, to Roberto and Marco Zangani of Vodafone, how they see, let me say, the trends in the standardization, but also the some of the practical issues they have to face. Many of us work on millimeter wave. There were a lot of speeches during the sessions of sub-TeraHz, terahertz. Then we see what are the difficulties of the operators. So Marco Zangani said very clearly, technology is here. We have the spectrum because they bought the spectrum, but there's no ecosystem. They can even have some applications where 5G millimeter wave can be used. So let me go faster to one slide. Okay, I want it to be faster. I think even if this slide was somehow summarizing the vision of both Ericsson and Huawei, so the move from the triangle, let's suppose the triangle here of I2R for the 5G, they said to an hexagon, then to a 3D pyramid in which we are adding applications, services, and of course the challenges on the technology in order to fit these services. And we have seen how sensing is becoming one of the most important pillars for the evolution to 6G, and also the intelligence. Ericsson spoke of connecting cyber, so the digital and the physical world, connecting intelligence. So we moved from collecting people, connecting things, connecting intelligence in this evolution with an increase of throughput capacity, requirements of latency. Roberto Farina of team this morning said how challenging is to achieve certain latency performance figure, and this is one of the parameters the operator use to check the satisfaction of the users. Spectrum, but now, since that was the topic, if you want to see, I'm sorry that you don't have a monitor over there, but here we are talking of this smart electromagnetic environment. We know very well that the propagation in millimeter wave, and even more if we go to higher frequency than 26, 28, I think you know that while the US has already allocated 39, the European Conference on Post-Secondary Education has already put the 42 gigahertz from 40 to 43.5 as the next millimeter wave band. Discussions on potential use of frequency bands above 90 gigahertz for the 6G. And here we have seen presentations about the smart skins, so passive, not reconfigurable, non-specular mirrors done with meta-surfaces. Professor Di Renzo introduced RIS, so reconfigurable intelligent surfaces, while Professor Antonio Capone gave an overview on what we have to do in order to find an optimum deployment, in order to minimize, or let me say, optimize the deployment. That means minimize the cost for the operators. Also considering that we have other two network objects, network controlled repeater, that were mentioned as smart repeaters in the standardization phase of 3GPP, and the IAB node that should be like integrated and access backhaul, so to go to the street layer, give the coverage. And if you remember in the slide of Marco Di Renzo, the direction, so the smart skin is the simplest and lower cost, but also with, now if Andrea Massa listens to me, lower performance down to the IAB node that can grant certain performance and quality, but of course at higher cost in terms of power consumption and cost of the hardware. So if there's any question on the topics from the audience, no audience?
Maybe I can
yes,
broke the ice. Question for Professor Di Renzo. We talk a lot about this RIS and this reconfigurability. We'd like to know, in your opinion, for this topic and the related very high frequency that we would like to use it, what are, in your opinion, the key technology that can enable this type of device?
Thank you very much. Yeah, so that's a very good point. So a very good question. So first of all, I see two things, two main ingredients. TeraHz, so very TeraHz and sub-TeraHz, let's say, plus basically to use these MIMO surfaces. So these two things together for various reasons. First of all, I would like to say, as I briefly said, that just a few days ago, there was an ISG, industry specification group, established within the ETSI on TeraHz. And really, there was a lot of interest. It was approved already by ETSI, and we will start soon. The idea is not only to work on TeraHz on its own, but also to find the synergies between the surfaces and TeraHz. So this is something that seems to be quite timely. I like a lot this TeraHz because it has some different features, different properties with respect to the conventional channels. So the channels start being more deterministic. Of course, we need to transmit a shorter range because it's very difficult to basically to reach very long distances. Therefore, indeed, basically, we will need to have a large antenna arrays. Now, call it antenna arrays, call it surfaces. it depends on how you really want to implement them, but we will need them. So in many of the slides, from Merwan, from myself, we saw these large surfaces, these large arrays that are communicating with each other. So they really
So and this basically bring new opportunities for us. So if you can hear me, I can hear myself. We can. But I try. Okay. Can you hear us?
No, it's not the microphone.
No, it's the power of.
Don't touch it.
Yeah. Okay, so I will try to speak about it again. So I see the network. This line. Try to each one about the network. So that we establish this high rank channels in the network. This special reflection network line. And we always have seen the line of sight as a problem also as a bit like one set. But if we go back to the past, we will see that at the same time where there was a research in this specialization complex, there was a lot of research on the understand line. So now people are actually visiting it's a nice place from the old example and there's a lot of discussions on this kind of data. So I think that having high frequency transmission is very high frequency. Very short range of channels in the line. The conversion basically makes so I think going back to the findings, I mean, this is very much it's a major problem. All the results that are very coincident. These surfaces that look are parallel to each other, which they are not in practice. That's the surfaces that are aligned with the polarization. And I think this is a lot of money. But maybe, I mean, it's not just as much so interesting for some things. But there is and of course, I mean, it's not only using the surfaces, multiple filters, but it's also actually to integrate some different surfaces. From the setting point of view, I think that there is a strong connection between improved minds, special materials, and improved surfaces. Because I mean, the missing element is usual public. So basically, everybody knows the usual public. But then, I mean, once you work about the stuff, very important. The usual models that are used for surface space applications, usual public does not show up. You see that there is so many of us are being trying to figure out this connection between minor rays, minor surfaces, and I think that this is really the TeraHz really make it more. They make for this question very much relevant, much interesting for us. It's relevant part of the opinion. And I need to say that every time that we look at minors, dense minors and layers, usual couple, the usual question that the usual complaint that we get from the data community is a data. It's already there now. But indeed, it's not really the case. Usual couple is always included as avoid, compensate somehow, but not to exploit. And also has never been studied sufficiently for effectiveness. Even in textbooks, we somehow so I think that there is a many opportunities for, transition to electromagnetic information theory or electromagnetic information theory. And it's very much exciting and fascinating. I never attended events like this or data materials or chemicals, so I started attending them and I find it very much exciting. So this has least been our single futures interesting to study any practice what we name it. And these are the kind of tools that comes to my mind.
Yeah. Because this answer, then literally two questions, then let's see Damiano's results. One is what everyone said about EuMA. I remember seeing papers in which they were saying that EuMA is comparable to the nanosite. I also really think that EuMA will be successful for nanosite or for, say, non-nanosite.
Yeah, I think so. EuMA is a special case of this massive thing. As far as I'm concerned, I haven't seen breakthroughs in terms of capacity. Being able to create things using it in waves, huge amount of kind of research just to do with these true properties. And using EuMA, which we write reduce plastic. And in terms of the guidance, as you know, we have been shown big hype was for some reason. and then since we which in which you read the paper turns out to be true. But it depends on the configuration you take. So you do a certain configuration. For certain configuration, you can improve. But still, basically, at the end, it's mostly the next thing.
It's 10 years that we are in the state. Flashing our head on EuMA or EuMA without finding a efficient way to make these converge.
Yeah, of course. Yeah, I think you've been working at vessel beams and you've been adding all these different things, and it's true that but there are scenarios where you can make. Where I was surprised with Tom Glenn is the non-line of sight scenarios. There may be something there that you can do. I haven't seen something. But I believe in this mode stuff because there are ways, especially by reaching into the models of this near field stuff, you reconsider the way you structure your matrix.
I don't know who was this person. So I'm wondering if you have a chance to choose whether to optimize your base station transmitter, be more similar to a radar in some sensitive environment, or more similar to a localization system, precise position the users, which way do you follow, which one do you prefer, according to each application.
You choose. So, the radar community has been existing for since more than 100 years. So, it developed a lot. And now we are rediscovering the there are a lot of fellows that actually got it exactly. There's 8 weeks. I answered the because when you consider that the target is the point, it's a nice paper. So, and you see a lot. And so, this is one of my introduction. Now, it depends on the business. So the answer to you is because if there is a service that you can sell, then you put really the sensing on the base station. And this sensing is important. So now, how much does it cost? But again, the base station has a higher power than the spectral sensing. So that means that spectrum for sensing. But on the other hand, the operators pay for that spectrum. So without tell the operator that use spectrum for sensing, they don't get anything. So, as usual, it's a matter of money. And so it's a matter of taking any method. So, who comes first? Willing to go there. Now, from the data point of view, right, from a practical point of view, I wish that Mark was really pushing that direction, which is not just branding as a 6G, but it's really neat. The only need I see is the vehicle, because there's someone that might pay for that, like insurance. Insurance or whatever. And that is a possibility. You don't really need much of a pedestrian. Okay, because yes, this is safety, but think about if you tell the car or the vehicle you offer the service that
yes. No worries. No.
You want me to come there? So, I'm not really much believing that there is a business on pedestrian recognition because, if you don't recognize a pedestrian and you make a crash and you injured the pedestrian,
And the base station is not alerted about that. So who is the responsibility? And that's a trouble. So you see, so the liability is limiting the overall penetration for the pedestrian. For the vehicle, you can say that you have all the sensor and I can just augment your capability. But you know, I mean, I still label that, you know, his recommendation is not that it's mandatory. So you can take this or not. So this way is a marketing possibility and is a business possibility. So I don't know if in a way or another I answer to your question. I mean, probably it's not much technical, but is, you know, is business oriented, and I mean, money is moving everything. You know.
You said that one comment that Tongwen made, and I had agreed with that, is we're not using enough basically the sensing capability to improve basically the communication that we're doing. And what he was showing is that by reconstructing your environment, even by vision, I mean, you could use vision to improve beamforming, for example. So of course, if you can go up to the texture, even in the environment that you can construct, then you could come up with some schemes which could basically benefit in terms of how you drive the signal, stuff like that. So I think on top of the classical business, there's a way of using all the different range of frequencies that we're having up to the optical, let's say, to be able to use that information as a way to do, because you're reconstructing finally a simulator, which is even a digital twin, and rerunning and everything online to do it. That would be like the futuristic stuff, you know? You're able to immediately get everything you want, rerun what the scenario and do some prediction with latency, whatever you can. So I think there's a lot of maybe ideas for improving the system on top of the market opportunities.
The impression I have also is that the value of the communication part of mobile radio network is going down per unit of spectrum, while the value of the service is including you know, the service that you can get with sensing is going up. So my impression is that it's not impossible that at a given point it will be more important to look at the efficiency of the sensing part rather than the communication part, considering also the type of capacity that we will get with the expansion of the spectrum. So I don't know. I mean, the sensing part is new, and for sure is adding much more value than what we are struggling to add with the communication, only because, of course, you know, this, you see the problem that there is in the telco sector in terms of the basic economics that you have, right? While the sensing is something new, that cannot be done in a different way with different technology, because you need different devices and everything is radically different. If you have the ecosystem, you use it. Why don't you use it using it for sensing and extracting economic value? So the point is how much this kind of technology will be used for extracting economic value. If this will be the case, and vehicular applications are, of course, the most important ones, then for sure we can even consider that some of the future standards will be influenced by these needs.
Another question, yes, please.
Thank you for your explanation. I had a similar question from different angle, because here in the room and also in the papers, we saw a lot about millimeter wave, about sub-TeraHz, 150 gigahertz. And I always ask myself, in sub-6 gigahertz domain, do we know or we reach all the potential of sub-6 gigahertz, the channel propagation? Are we know the model of the environment, or our base stations that now we are deploying at 5G is optimum for sub-6 gigahertz or no? You think that this research field is quite saturated and is not interested anymore, and we need to always talk about the millimeter wave and higher? Especially, frankly speaking, about 3 gigahertz, 6 gigahertz, 5 gigahertz, this is the bands that we also see from Vodafone, very interestingly. They're very interested because it's more realistic and there's a market there.
That is certainly a good question. And let's say the following. I mean, I came here, but for me, already going to terahertz was already a big question for EuMA2Wave, because I haven't seen already mobile
millimeter wave working for 5G, for just the problem of beam alignment. And a couple of years ago, everybody was telling me that due to the situation, millimeter wave will be for 6G and terahertz will be for 7G. that was basically because for the moment we're doing fixed access and we have to do mobile infrastructure, and it's not mobile. Millimeter wave, we can't make it. There's so much problems. So what you're asking is certainly true. We're moving too fast with respect to basically using already millimeter wave and not terahertz for classical mobile communication. It's not working. There's much issues, uplink, downlink, things like that. Now, in terms of exploiting the full potential, there's different things. In coverage, I think we did it. There's certainly some things to do in capacity, but then there's so many other metrics that we could look at exploiting those kind of bands that we're doing. And I think just on how we aggregate the different bands, things like that. All the other metrics, I think there's still a lot of things to be thought about in the sub-6 gigahertz. In terms of coverage, I don't see what you could still do in terms of innovation and new type of things. Capacity, there are still a bit of things to do, especially for non-aggregated bands and improving with the models, channels, of course, that we're talking about. And then all the new metrics which are coming up. And one of the metric is, of course, energy efficiency and all these things. I think there we're missing a big point. We haven't touched upon this. I mean, there was one person, I forgot who was talking about energy efficiency, green, and what Ericsson. Ericsson was mentioning these things. I think this is a big issue for all of us. I mean, you see today how people are against us. I mean, I'm happy because 2 weeks ago I was in a conference called Gritzi. Everybody was against me when I was talking about 6G because they said, oh, you're polluting the planet, things like that. But you have to know that there are people out there who are very, very against the technology evolution that we're doing because we're not taking into account this thing. And I have to confess, from that point of view, I mean, many of you, I think, were in consortium in 2010 called Green Touch. I don't know if some of you remember. That was like a big consortium with the goal of reducing by a factor of 1,000 the consumption by 2015. And we worked hard, by the way, so I was working intensively with the guys at Bell Labs. Of course, some technologies emerged from that. By the way, that's not a bad thing. Maybe you don't recall, but massive MIMO originated from Green Touch, for people who don't recall that. And it was considered as a green technology at that time. Because in the uplink, which now everybody's against, but at least mathematically speaking, when we started to do the hardware, it became a nightmare. But mathematically speaking, the idea is that by adding more and more antennas at the base station in the uplink, you reduce drastically the uplink power. And in the downlink, there's a beamforming gain. And so you reduce drastically, and it was stamped as a green technology until we started into making it with all the problems. What I mean here is that on all the things that we showed, I think we're still missing this point, and this metric, we have to work on it. Otherwise, we'll get a lot of trouble for 6G, I'm quite sure.
You know, I mean, let me see what I foresee. You know, I think that, as you said, you know, millimeter wave is still an issue. So in mobility and so, and you know, as Antonio was saying, I mean, we have this project on a high-frequency campus that we want to test it. Probably we will go up in frequency one day. But you know, the high frequency on the terahertz, let's say, is very nice for sensing, because you get a very high resolution with that. So you can use 2-3 gigahertz for sensing, 5 gigahertz there for sensing. Then you know, you can easily see, as you see almost with optics. And so that's important, that one, you know. I mean, on terahertz, we still have a higher attenuation than with millimeter wave. And so, I mean, we can make a very accurate sensing. And so that is one aspect. So very luckily, that is another impairment that we need to take into account, which is, you know, every time we rise in frequency, I mean, there is a dust on the antenna, it creates attenuation. So, and this happens on 200 gigahertz that we have a test, or 200 something that we have tested at Polytechnic. But, you know, I mean, in case you go up, everything that goes in front of the antenna is attenuates. And so, you know, at a certain point, I mean, I expect that the TeraHz is a nice exercise to make sensing and sensing for cellular phone, let's say, because it might replace the laser or the LiDAR that is on sensing for the face, or some biomarker that is complemented by the electromagnetics on the TeraHz side. And so this one is the scenario. So, I mean, even if, you know, I see on the TeraHz side working on, I mean, as a 6G, I believe that, you know, millimeter wave with some enlargement of the spectrum might be enough for what we need, you know. It's not really serving for virtual reality on the movement, perhaps. It's not enough in that case, but, you know, I mean, for most of the case, I believe it could be enough. I've no forecast on the possibility that, you know, virtual reality devices might penetrate. I've never seen one, I don't want to use one, and I'm not familiar, so I don't know.
If I can comment, because it's in 32 years I'm working in this business, I've seen one real major trend, that we have to go higher in frequency in any case. This is, but then there is another thing that is very important, or two things. First, normally the services or applications that use the higher frequencies are the easier, so line of sight communication. And that's why, for instance, point-to-point backhaul is already using, and is mature technology, the 70 gigahertz. That is not definitely mature technology for access. For the D-band, we have seen also the presentation by Ericsson. We made also a lot of work in Huawei. Is the next step, because we can have very wide channels, and we can transmit up to 25 gigabits per carrier. Technology is developed, and then also the access will move on, because 2G started with 900 megahertz, then 1.8, 2.1, 2.6, 3.5, 6 gigahertz. We will move to millimeter wave. And then millimeter wave probably is the chicken-egg dilemma, no? Because Marco Zangani said, we have the applications, we have the technology, but we don't have the ecosystem of the terminals to justify operators to invest. I think that if applications were big enough to justify companies to invest in the ecosystem, this would start. So it's really the chicken-egg issue. So I think sooner or later, we will go step by step in increasing the frequency, we'll change the type of service. Of course, we cannot cover distances. The second thing is, and it's very complicated to calculate. It's a very good question. Can we still exploit the sub-6 bands in a more efficient way? The cheapest way to transmit more capacity is by using more spectrum, from hardware point of view, from energy point of view, in a single connection. Then, of course, if you make a base station at 26 gigahertz, you need more base stations if you want to cover what you can give with, I don't know, 2 gigahertz. And so this is a very complicated TCO to make, how many base stations, power consumption. There are some studies by GSMA and by other organizations that try to find what could be the optimal way to use a spectrum from this point of view. And it's really very, very complicated for access.
Point of view on the public. I think Renato is the bad guy in general. I mean, when you talk whatever higher frequencies, and the adoption is not also public-wise is not good. We know it. I mean, at the moment we start talking about anything which looks like a microwave, you know, people get panicked. So maybe you have to change the name or something. But I think this is also an issue that we'll face a lot. I mean, we're in a community where we understand ourselves, but I often go in communities which are, let's say, normal, and there any issue with millimeter wave is considered as a no-brainer. You should not use it. So I think this is, I mean, maybe you're doing it a lot in your ITC stuff, things like that, but there's a big issue today of these frequencies just because people don't understand what it is. So.
Actually, and then we can close with a joke. I hope that the ISG terahertz that was mentioned before, we start defining proper names, because we have microwave, and we have millimeter wave. There should be longer wavelength than microwave. Then we have sub-TeraHz or sub-millimeter wave terahertz. So I hope we can come with some definition.
I mean, he's right. I think naming is important. I mean, the Wi-Fi guys are very smart people. You know, they do Wi-Fi.A, B, C, D things. Whereas they increase the frequencies, they increase everything. Nobody complains. But when we go from, we should have called it 4G-A, 4G-B. We did 4G to 5G, everybody panicked. You see what I mean?
We have V-band, E-band, W-band, D-band, G-band. We should follow the alphabet at least. Okay. With this, I would like to thank the speakers, the panelists, but also Roberto that is still here from team, and all of you, because I admit it's been a very long day full of topics, and I hope you enjoyed this forum. So thank you very much. And for the ones that stay here, enjoy the conference. Thank you.